My name is Jonathan Martinez. I am an assistant professor in Aarhus University. Today, I will present a topic called Toward Next Generation of Planning and Control through Digital Twin Construction. I think this is a topic that you might hear about, right? Many times, digital twin, digitalization, etc. But we need to take the time and think about what do the construction industry need to be digitalized? What the digitalization matters, right? This is a common question that maybe most of the people, especially out of the academia, ask. What do I need to have a bunch of technology working together to collect data? What is the purpose? What is the current method is not working, etc. Because digitalization requires a lot of investment and a lot of also capacities into the people that work in construction. Okay, the first of all, before to talk about what is digital twin, etc., is why digitalization in construction matter. Is because has been proved, especially in the academia, that the digitalize the construction process, increase the productivity and efficiency, due to allow us to automatize many tasks, right? Allow us to enable real-time evidence based on decision making, reduce the waste and carbon emission, improve collaboration, enhance safety and compliance, and strengthen competitiveness in a digital-first market. This is most of the answers that you can find in the literature. But at the end, digitalization allow us to shorten the production, the plan, do, check, and act cycle, right? I think you have been hearing this many times, especially in the lean construction classes, or maybe in another courses oriented to administration, right? In our way of thinking in construction and other industry, we have this cycle about, okay, we need to plan, we need to plan, do, check, and then act, right? But most of the time, this circle or this system is delayed in construction due to we don't have enough evidence of what is happening on the site, and also we don't have the capacity of design over a solution because we don't have information about what is happening, or we don't understand the current status, right? This is why the digitalization matters. Digitalization allow us, talking about construction process, allow us to take better evidence in real time most of the time, and then decide what to do and propose better solutions. This speed up the process, actually. This is a common graph that I show usually at the beginning of classes like digital twin, because digital twin is our advanced system. It's an advanced system. It's not something that you can create from scratch. Require a lot of computational skills. If we are talking about a full digital twin, integrating sensor, reality capture devices, etc., right? If we think about an integration of several technology and one single system, it's require a lot of computational capacities and technologies. And in the manufacturing industry, for example, we had 4 revolutions, and now we are in the 5th revolution based on some author. But in construction, actually, we are still struggling in the industry for 3.0, actually, because now we are pushing the automatization in some areas, but we don't have full integration of all the systems into one single system, as the industry 4.0 promote in the manufacturing, right? If you go to, for example, labs or pharmaceutical industry or car production line, you can see that most of the processes are automatic. Most of the decision, or the majority of the decision, are taken by machines, computer and controller, instead of quality, instead of production rate, instead of speed of the production line, right? In the construction, most of the time we have a manual process to take this decision. And this is because we don't have the capacity that the manufacturing industry has of install many sensors, many devices, many computer systems, or artificial intelligence all together to make this decision for us, right? And this is what I have been trying to make, actually. What the topic that I'm going to explain is one part theoretical, and the other part is a practical example how this technology can be implemented in production planning and control. And this is a research that has been conducted. I have been conducting this type of research for almost 4 or 5 years. And now we're still working on that, because it's never ends. To have digital twin that respond to changes to planning and control is a massive work. And also because most of the time you don't have this information. You will see what has been done. And recently it was published a paper in automation in construction. Also, you can read it And you can see what is the state of the art in this area now about planning and control using digital twin. Okay, what is digital twin? I will be fast in this area for sure. Professor Dayana has explained you too many times, but there are many definitions of what is a digital twin, depending of the author or companies. Digital twin, for example, could be a digital representation of a world entity, and also need to have a connection, right, between the real world and the virtual world. Also, for example, Microsoft said that Microsoft is a virtual representation of a physical object or system across the life cycle using real-time data, enable understanding, learning, and reasoning. Okay, most of the definition here has some common words or common terms. The first one is a virtual replica, and the second one is a real-time data, right? It's how the physical world can share data with the virtual world, and in the opposite way as well, right? Because you don't have a full digital twin if you don't have the connection between the virtual and the physical as well. It's not only the physical and virtual, it's also the virtual and the physical. This is what we are going to see here in the next slide, for example, and on the next no. But this is some example of a digital twin in different industry, in the aeronautic, in the car industry, in the manufacturing industry, in also digital twin cities, right? We have this digital replica about the performance of cars and planes, and we can play with the digital replica in order to simulate different flight scenarios or different crash scenarios. We were talking about cars. We can model, for example, some scenarios or risk analysis with cities. But to most of the things that you can see here in this slide happen, it's necessary to have a bunch of data, right? And the data is the essential part of all the digital twin system, right? How we are going to collect the data and what data is relevant to understand the behavior of these physical assets. For example, I don't know in Brazil, but I can tell you here in Aarhus and in other cities in Europe, they have digital twin cities. It means most of the information, especially the public information related to, for example, how many people are in a specific places, for example, public places at that moment and at a specific moment, how many empty rooms are in the major or on the public buildings available, what is the consumption of energy, current consumption of each public building. Most of these things are available or have online access. Most of the time free and open access. So people make analysis based on this data, right? Then they have a lot of sensor distribute around the city, collecting data that at the end transform this in a kind of digital twin. Once they use this data to simulate, predict, or trying to change some parameters and see what is the behavior of the physical asset, right? And this is something that happened in many European countries and in Asian countries as well. In United States, also they had some attempts of doing that, but the public data is very sensible and it's not easy to get data from people and also for public building, etc. And this limited, obviously, the development of the digital twin system. Okay, these are the main components of a digital twin. You have the data environment, that is the central core of everything, right? You need to have a centralized database where you collect all the data, from different sensors, and then you transform this data into meaningful information, and then the information is transformed into knowledge, right? What is knowledge in all this digital twin cycle? The knowledge are the KPIs, right? How we can use, for example, the position of a worker, longitude, latitude, and altitude, and then transform this data from the workers into a safety indicator, into a risk indicator to understand, okay, what was, for example, the probability or risk of in certain area based on the location of the workers and the time that the worker spent in certain area. You see, it requires all the position of the worker, that is the data, longitude, latitude, altitude, also require information from the schedule to know what it's supposed the workers will be performed in certain periods of time, Also will require information from the BIM model to analyze what element they were involved, construction elements that were involved in the building process. And also it will require information from another sensors, right, to understand, for example, the safety boundaries around. You will require too many things only to analyze a safety indicator, right? And this is part of the knowledge. That's because digitalize everything is not an easy task, right? You need to understand or make an analysis from the top to the bottom to understand what data is required and transform this into KPIs. And in the central part of the digital twin are this data environment, how we can transform this position into an indicator, right? And to do that, you require to implement something called complex event information system, which help you to merge different data from different type of sensor that most of the time are not compatible into one single system, right? Maybe you can get the position of the worker every minute, but at the same time, you can get information from cameras every second, right? And there is no a compatibility in times in the data collection, but you need to create a system that make compatible all this data from different data sources. And this is not an easy task to make. It's not impossible, but it's not an easy task to make. And this is one of the most important tasks of the digital twin system and in the data environment process. Okay, are you listening to me, right? Hello?
Yes, yes.
Okay, sorry, because I didn't receive feedback. I was worried something happened or something. Okay, we had different type of digital twins, right? Or what we call digital twin in the market and also in the practice. I had a visit to the United States a couple of weeks ago, then I traveled to California to see what was the implementation of a digital twin system in a construction project. For example, huge companies there call a digital twin only a digital representation of the physical asset. This means they call digital twin of a building only to a point cloud collected by the LiDAR or collected by the UAV, right? But I told them, I tried to challenge them, okay, a digital twin has different level of maturities, and also you can call a digital twin something that is connected in both ways, from the physical and the digital object, right? Most of the development that they have were only related to using real capture devices like RGB cameras, point LiDAR, etc., right? But with no connection and no possibility to modify certain parameters of the system. For example, what happens if I modify this? What are the affectation in this area of the building? Nothing, right? And there is a misunderstanding about that. But this is the level of evolution of a digital twin, right? What most of the people are making, most of the people call digital twin, actually is a digital model when you have this point cloud, right? Then you have the digital shadow, right? That this is an intermediate level between what a digital model is and what is an actual digital twin. Is, for example, when you put some sensors on the building and then you get information into a dashboard and then you project the result of the data collection in a dashboard. For example, I saw a lot of digital twin, incomplete digital twin in Finland, and when they had some sensor, humidity sensor, temperature sensor into the apartments, in order to understand what apartment were ready or not to flooring, to the flooring process, because they had to do it to the temperature and the environmental condition. They need to guarantee certain characteristics of the apartment and floors in order to be or to work to workers work in the area, right? And they had a projection of all the apartments in a in a kind of 3D model, where you can see where the apartment, which apartment were ready or not, based on humidity, based on the temperature, and also based on the availability of material. Because Danish company, or this specific company in Denmark, in Finland, sorry, I talk about Finland. I mix a little bit of Denmark. In Finland, before to work into the apartment, they need to have the environmental characteristics plus the materials inside the apartment, right? And all the materials were labeled with a QR code in which they had instruction for installing the elements into the apartment, right? And all this information were displayed into a dashboard, and people can see, okay, apartment 1, 2, 3 are ready to work, I can send this and this and this, right? And this is a very good solution actually in the construction. Most of the construction sites doesn't have this kind of advancement of technology application to understand the availability. But they claim that this was a digital twin, but this was an incomplete digital twin because there were no replica from the physical asset to the virtual world, right? They need to from the virtual to the physical asset. There were not a kind of plan instruction, right? When you receive, for example, from the system, okay, based on what I am visualizing, based on what is available now to work, create me a production plan, right? With the two crews that I had available to coordinate these two crews and give instruction to go to which apartment first, and then in which apartment they need to be continued in order to guarantee the flow of the project. No, it's only the decision were taken completely by the users. Okay, now what is a digital twin construction? Imagine, okay, we have this concept about the digital replica with the physical asset, etc. But what is a digital twin what is a digital twin apply to the construction job site, right? Professor Rafael Sachs create a concept called digital twin construction, right? That this is a concept that I have been used for my papers or for my open research, right? And evaluating also companies based on the maturity in the implementation of certain technologies to understand the level of adoption of future technologies like digital twin. And we had this concept about digital twin construction that is an advanced construction management paradigm that integrates real-time data, predictive analytics, and virtual modeling to optimize planning and control and execution, right? Basically, this concept has been or is used in the construction phase, right? And you see that encourage the use of sensor real-time data collection and all these systems that give you a process or a sense of real-time information for decision making. This digital twin construction paradigm, right? Based on this paradigm, there are various platforms that has been built based on this concept. It's divided like in four axes, right? An axis about lean that include the planning process, another axis about BIM, the automated data acquisition and artificial intelligence. He believe or he think that all these four components are mandatory to be implemented into a digital twin if we want to orient this digital twin for production planning and control, right? And this is like the main visual concept of what he thinks that is a digital twin construction, right? And you can see here how the physical asset is transformed into a digital twin, right? Through different stages, right? In which first we collect information from the monitoring, right? Using sensors, and then we use this monitoring data, monitoring system, and then we collect raw data. And this raw data using the database, right? And what we call complex event information system is fusion with other data in order to have information and knowledge. But the interesting thing here is that, for example, sorry, this is in order to understand if the production system is underperformed or is on time or is delayed or etc., we need a kind of comparison between what we planned initially, right, during the planning process of the project. And this kind of digital twin system requires to have information about what is happening now, right? What we collect on the site with the sensor, with the drums, with information that the workers can provide using apps, etc., together with plan information that he called as plan information and as design information from the BIM model. And then we can compare this as plan and as plan and as design together with the as perform and as build, right? And all the digital twin system into the database process compare what was planned and what is currently has been developed, right? And once the system detect any anomaly or discrepancy between the plan and the actual, he trigger alarms or trigger actions into the system in order to user take decision, right? In this case, we use it because we build a platform based on that. We use a simulation in order to try different alternative plan or production plans, and we try to see based on the simulation what was the best or optimal plan can solve the problem of delay, quality, etc. Right? And this is all about the main concepts of the digital twin. And you see that also the system rely on historical information, because all the time that the system is running or collecting data from the users, from the crews, from the suppliers, etc., is storing the information in a historical digital twin, in which this information is reused for the next development or for the next phase of the project or for other similar projects. And you are, or maybe some of you will ask yourself, okay, but there are enough technology that can help me to understand what is the current status of the site, because the current status of the site is huge, right? You need to know, for example, the physical progress, right? You need to know the amount of work that was performed, the amount of work that was performed per crew, the amount of work that was performed per stage. But together with the amount of work, you will need to compute some KPIs from the crews, right? For example, productivity rates, production rates, probabilities, for example, of bad quality or waste of materials. Or you need to also, because this system also include the area of the logistics. The logistics is important. You have material delays, this will have an impact in the production plan that you had available. You will need to know then how much, what is the probability of delay of certain delivery company or certain company that deliver the main construction elements of your project. You will need to have. There are the technology exists actually for most of the things that we have been talking about to know the productivity of workers, etc. But the technology most of the time is not compatible each other, right? You see, this is an analysis that Professor Sachs with another PhD student in 2021 made, analyzing all the tech companies in Israel, Europe, and some companies in America, and understanding what they offer, what type of solution they were offering, what data they collect with their technology, and what are the potential of the technology that they provide, right? And what could be the functionality of the use of this technology to have the current status of the site. You can see there are 26 companies here. I for sure there are more now. You can have a look later in this table or in this paper, and you can check the web pages of different companies. I work like with 2 or 3 here, Israeli companies, for example, Insight, that is about the computer vision. I work also for Build Docs, using 360 camera to collect videos or video footage of the job site. People walk around the job site with the 360 camera, collecting videos, and then using computer vision, they can compare the as planned with the as performed, right? The physical progress. And also they can detect some quality issues comparing location of window measurements, for example, with the BIM model. And they generate a report in less than 24 hours about the physical progress of the site. So some of the technology exists, for sure. Yeah, there are here, like, these are the technology that are core, and are core, obviously, to get data from the site. You know what is a GPS, etc. I'm not going to explain anymore. And what are the function and how they can contribute to the scheduling data gathered from the site, data monitor, etc. It's a good paper if you want to update the knowledge in the technology that already exists. This is a good starting point. And okay, you saw that there is a lot of things to making a digital twin system, data connection, sensor, etc. But this already exists. It's still possible to make a kind of complex system that I tried to explain before. Yes, I can say in a 75% actually, because implementing in a real life is difficult. We implemented in demo cases actually, This project finished in 2024, last year actually. And this project was founded by the European Union. The idea was to build a digital twin system, right, platform for construction management that implement lean principles, reduce the operational waste, shortening schedule, reducing costs, enhancing quality, and reducing carbon footprint. You see, it's a very ambitious project. And when you target these ambitious indicators or goal, it's very frustrating when you don't get it, right? It's because this project tried to cover all the problems that we had in construction management. And this was the project actually, and all these are the participants, most 18 institutions. Usually European Union projects require the involvement not only of research institution, but also construction companies to validate the solution, and also another is private institution that contribute also with knowledge and products. Okay, this is the main design of the platform. Like I cannot show you the ontology because the ontology has not been published yet, but this was approved, but this is not public now. But the ontology is all the data schema, the structure of the database. You can find some on the internet in which we mix the information from sensors to try to get understanding of different part of the production system from the location level stage. So we make all the system based on a location-based method system, in which in one location, for example, I think was at the level of apartments. At the level of apartments, we knew what were the activities that need to be performed, what were we needed information about what were the crews involved in this location using a data structure, data schema, and what were the bin elements involved into this apartment. And this apartment belonged to a more broad location, and is a floor, and the floor belonged to a more broad location, and is a building, and the building belonged to a residential development, right? And all the information of the data that need to be collected to understand this level of granularity was published in a data schema. This is the first part that you need to make before to begin to play around with the digital twin. These are some screenshots of the platform in which you could see what was the physical progress. You could filter by week, by month, by day, what were the activities that were performed and the elements that were built, etc. To make that happen, or to make this possible, we needed to distribute the work between different institutions. For example, one institution in that case was a University of Cambridge, was responsible of using LiDAR system in order to detect the physical progress of structural elements, for example, to understand if using drone flies, and also using terrestrial LiDAR to understand, okay, this element was built or this was not built. Also, we had another university. I don't remember specifically. I think this is the Italian university. No, this is an Spanish institution, which was collecting information about quality and about quality check in different processes, right? Using computer vision. There was another institution in the project. This institution was from Germany, using data acquisition cameras, software analysis, and visualization data in order to understand the position of the trucks, of the heavy machinery, in order to understand the productivity metrics, in understand the value and no value at the time, to feed this data and information into the digital twin system. And you see all these solutions that were proposed for each university and institution needed to be integrated into the digital twin platform, right? But this data and information that they provide with the sensor was defined initially by the ontology, by the data schema of the system. And in my work package, in the part that I work, in Israel with Technion, we developed a simulation system, right? And this simulation system was connected to a digital twin. And as I told you before, recently we released the paper. I can send you the link later, and you can check most of the things that I am explaining here are in the paper, and you can further elaborate in some areas. But we create a simulation system that was connected to the digital twin. And this was the main contribution because at that time, when we began to write the paper, that was like almost 2 years ago, there were no system or simulation system connected to a digital twin platform, and that this simulation system has the capability to adapt the assumption based on real-time information. Because the novelty or the idea of having a digital twin is that you can rearrange whatever you want to rearrange. In this case, was the production system design. It means the amount of work that need to be performed, the amount of crew that will work for a specific day, the amount of material that will be used in real time based on data that you collect with the sensor on site, right? And we developed this system. As you can see, the system is integrated to the digital twin and has a user input interface, a simulation engine. We had a alternative plan evaluation system in which we evaluate different options, right? Every time that the simulation generates different options based on the initial parameters that we modify. And then we advertise or we post this information in a recommendation dashboard. Yeah? And this is like the data structure, how we conduct the process of the simulation. There are many types of simulation. I assume you have been reading several papers about digital twin, production planning and control, construction safety, and you can see a lot of simulation application, right? You can see now optimization algorithm. You can evidence, for example, Monte Carlo, etc. But this specific simulation is based in something called agent-based simulation. And this agent-based simulation is something that is not so popular in the construction domain because it's not an easy task. It costs us like 2 years of work to understand the behavior to understand the agents and the behavior of each agent in the construction and how they interact each other and how they produce the emergent behavior. It means the activities, right? Because if you recap a little bit in the construction process, the only way that someone, or for example, the crews perform a task is most of the time when they receive instruction from the site engineer, right? There is a relationship between the site engineer and the crews, or maybe the crew leader, right, or the subcontractor. And someone else needs to give instruction to another person in order to conduct a task, right? And this is all about human interaction, right? We map all this human interaction, okay, when the design engineer gives instruction to the crews, what happens if the crews fail in performing the task, what is the next? And to map all this behavior, we build behavior trees, right, or probability trees. Most of the system was based on probabilities. And you would ask me, okay, how did you manage this probability? How did you get these probabilities? Based on information that the construction project that we used have it previously. But also the idea is that these probabilities are calibrated automatically every time that the digital twin collects the system. This is the ideal scenario. If not, you need to provide the probabilities to the system because each company, for example, in Brazil, maybe has some different probabilities than companies here in Denmark or in the United States, etc. and to map all these behavior trees and probability distribution, etc., we use AnyLogic, right? And it's a software that give you the possibility to simulate using 3 types of simulation. One is discrete event simulation, the second is agent-based simulation, and the third is system dynamic, actually, right? But you can actually combine all this simulation together in order to have a robust picture of the system. And what was the purpose of the simulation, right? As I told you at the beginning, was rearrange the production system. But why rearrange the production system? Imagine in a scenario that you are building a building, actually, But most of the time, you had something called decision points, right? Each decision point are point in which you detect some anomalies, or the digital twin or the person in charge detect anomalies regarding the project performance. Okay, I had a delay of 1 week. What we can do, right? You stop here. And then the traditional method is to gather some people from the job site, right? And other people that understand the problem, had a meeting, present some photographical evidence, present the plans and the budget that they had, and then trying to come out with a solution that fit into the current budget. And do you think that this solution could try to avoid or minimize the consequence of the current problem, right? But currently, we don't have a tool, right, that evaluate this decision. Evaluate the decision, okay, if I take this solution that increase the number of crews from 2 to 3, what is the consequence in cost, in time, in quality and safety, right? All the consequence and modification of the production plan can have a consequence. And this is one of the tasks of the simulation system that we perform, is to try to evaluate the consequences of the decision and try to come up with the best optimal plan that the user can implement. And we, for example, using a user interface that I will show you, I think in 1 or 2 slides, you can see what are the parameters that they could modify and then come up with different plans. But this problem about rearrange the production system will happen constantly, right? It's not something that, okay, we rearrange the production system here and then everything is normal. No, it's something that happens reiterative. And every time you will need to use a tool or maybe the traditional method to rearrange the production system. And at the end, every time that you, or the simulation system that was created, receive this data or modification in the production plan, he generate different production plan based on the probability that is included in the system, and also that you can introduce manually and produce thousands of plans. And at the end, you will have like a compilation of this plan into the system, and then you will have not 1,000 but 5 or 6 plans summarized based on the changes that you make in the user interface. And this, what you are watching here, is one of the interfaces of the system, or a video in which you could see the current status first to analyze if there was a deviation or no, a comparison view in which you could compare the different alternatives that you create, some probabilistic graph or statistic about the probability of this plan can be performed on time or no, etc. And you had all this data and information. And this is how the system works, right? I think in the Beam to Twin web page of the project, you can find this software available also if you want to play around with different alternatives. But these are some screenshots of this one. For example, the system works in, okay, I want to generate some plans, or I want to generate some simulation departing from this specific point of the project. Then you will have some information about the current status of the project. You can see the work dependency, the work quantities, the cost breakdown, etc. Once you understand or have some sufficient situational awareness about what is happening, then you will go to the plan configuration, in which you can try or create different plans, right? For me, okay, for me, the first plan is to increase the crew number 1. For another plan could be increase the crew number 1 and crew number 2 in 1 person for each crew. Other plan could be increase the buffer size or reduce the buffer size of apartment. Another plan could be consider some variables, for example, about material delivery delay, or I can change or modify, for example, the reliability of the supply chains. I can say, okay, I will change this supplier because this supplier give me a certainty on 90% that the product will be arrived on time, etc. And you will have different plans. Yeah, I don't have time to explain all the parameters here, but most of the parameters, even 70% of the parameters, because I prepare these parameters here, are related to the lean construction production system. It's not based on the traditional or common planning method. You can see batch size, buffer size, etc., are more a lean construction perspective about production planning. For example, push and push logistic plan also is come from the lean construction. And then you create all these plans. And once you create all these plans, then the simulation, a hidden simulation, because you cannot see the simulation process, it's in a computer, begin to try or calculate all these plans using the behavior trees, the probability, and the parameters that you introduce initially, right? And this is basically the end of that. Okay, and to finalize the talk, I recently, not recently, 6 months ago, we published a paper about toward the adoption of digital twin construction system in Latin America, right? And this is something that could be useful also for the Brazilian construction industry or for you if you want to implement digital twins. And you will see that to implement this digital twin system, the company need to have a kind of readiness level toward the implementation of the digital twin system. It's not like, if you saw the Beam to Twin project, actually, what we made was a platform. It's something that we access online. We had credential user. You had the menu in which you can see the project progress. You can access the simulation. We had a system compile everything into a single database in which we retrieve data from the different applications, right? If you see the current development of the construction companies in Brazil, in Colombia, in which we made the study, what you see is implementation of different technologies, different software, etc., but nothing unified in one specific system. And this research that we made, we defined some criteria to evaluate the application of different components or different advancement in technology in the company, was to understand if the system that they create or they are trying to create, putting drums, putting RFID, using the best BIM software, etc., actually is a system or not, right? Because if they want to go to the digital twin construction system or implement digital twin construction, they need to create something unified, right? And we try to understand, okay, what type of database they have, if they are using only Excel data sheet and they are using a common data environment only for the BIM, but for example, for the current status, they only use an Excel data sheet, but there is no cross collaboration between the information from the site and the information that is contained in the BIM model. How much time they update the BIM model? They had an as-built BIM model only at the end of the process, or they had an update BIM model every week that they can use to compare the progress, etc. And we make all these thing that also was published. I know what the title is in this position, and you can see what are the requirements, parameters, and also practice that lead to the companies to have an actual digital twin in the construction, right? Only to show you a little marketing to show you that we are creating this kind of tool and this kind of thing to understand the progress of advancement of, especially in Latin America, in which we are lag behind of Europe and America as well, North America. Thank you very much.